Hello. Let's look inside this torque converter. We rarely get to see the insides of one, but that's what we're going to do today. Before I do this, just want to point out, this one's been cut apart. You could never buy one like this. They come welded together, okay? And so this particular unit, we put on a lathe, and we was able to cut the weld off just enough to expose this and look inside. It's a great thing to do. So here we go. The first piece that we need to talk about, or the first element, is the pump, sometimes referred to as the impeller. As you can see, it's got all these wonderful veins and this guide ring, and the fluid actually gets picked up, and these veins are thrown against the turbine's veins. We'll get to the turbine in a bit, but the pump is what influences or starts to spin the turbine. The pump is always rotating so long as the engine is running, okay? Not only that, on the other side of the pump, the torque converter's pump, is a hub, and that's where the front pump seal, the torque converter seal rides, right? Notice these little lugs or notches here. Sometimes they could be actually recessed notches. This is what drives the transmission's pump, okay? So this reaches in and turns a gear inside the transmission. And we'll get to that later. So the torque converter's pump turns the transmission's pump, which makes sense if I'm going to have any hydraulic pressure at all, okay? So that's the pump, or impeller. The next piece we'll discuss real briefly is the stator, okay? And it is stationary at times and locks up the other. It's got a one-way roller clutch inside here. And when we're cruising down the road, for example, it's just kind of freewheeling along. But when we all of a sudden accelerate to pass somebody, or we're starting out from a stop, this locks. And these little fins right here redirect fluid to help the pump influence excess added pressure to the fins on this turbine. And we'll show that in a moment. So again, this is the stator. It's got these little thrust bearings on each side because, again, it's suspended basically inside the torque converter. It doesn't really touch anything but fluid. Okay? And of course, here's the turbine. This is the part, if it's rotating, this element, if it's ever rotating, the wheels are probably turning because it's splined to the input shaft. And of course, the clutches would have to be applied inside the transmission, but just for now, we'll just say, if this is turning, power is being delivered to the input shaft, which obviously is going to result in movement of the vehicle. And that's what these splines are, again, for the input shaft. On the back side of this particular turbine are these little teeth that engage into the torque converter clutch. And these springs here cushion the engagement when the clutch is applied. And let's talk about that next. So I'm going to pop this out. Here's the actual clutch piston with the clutch lining, okay, kind of like brake lining, I guess would be one way to explain it. And again, sometimes you'll see these cushion springs inside a torque converter. And again, the notches, or these teeth, that we pointed out earlier, sit in here, and it'll help cushion when this gets engaged. Here's the clutch surface, okay? And so when we want to engage, when the TCM, wants to engage the converter clutch, it simply pushes this against that part of the converter's housing. And you'll notice right here, there's a seal. Okay, that's to help seal some hydraulic pressure. And again, this converter clutch piston, side, it actually slides a certain amount to engage or disengage the torque converter. Okay. When this is engaged, it's what it's doing. It's locking the turbine to this housing, which of course is welded to the pump. So let's talk about this cover, this other side of the torque converter housing, or the cover, okay, area. There's a pilot, and this pilot rests inside the crankshaft. There's a specific diameter hole in the crankshaft for this to ride in and rest on. And this helps keep the torque converter, when installed and operating during the life of the vehicle, it helps keep this converter centered with the crankshaft and, of course, the input shaft of the transmission. So again, that's the pilot. These pads right here for bolts, this is where the torque converter gets bolted to the flex plate. Sometimes you'll see 3. This one has 4. You might even find 6 on here. It all depends on the configuration of what the manufacturer has chosen to do. So again, these are welded. Now the bolts that will go in here are specific in length. Or if there's studs in place of these, the lock nuts that go on the studs are again specific by application. Don't just get any old bolt or any old nut to put on here if you want this to stay fastened to the flex plate. Okay, again, the crankshaft is powering the torque converter because it's bolted to the crankshaft in essence. Okay, let's do something even a little more fun now. We're going to assemble all these components now to the front of this transmission. This smaller shaft is the transmission's input shaft. See how it rotates? This larger diameter shaft is called the stator support shaft. It does not rotate, never does, okay? The input shaft, again, is what the turbine is going to engage with and, again, power the transmission. So here we go. Here's the pump. This hub reaches inside, and here's the front pump seal, or the torque converter seal, okay? And we're going to drop in the converter. And we got to rotate it around so that those 2 lugs can engage with that pump drive gear, the transmission's pump drive gear. Okay, and here we go. There we go. Next, we'll put this piece that suspends the stator. And of course, it is supported by the stator support shaft. I'm going to go the other way with it. There we go. Now, the engine is running, right? And let's say it's throwing fluid against the vanes of the pump. Okay? So while we're accelerating, this is stationary, and the fluid will actually hit a part of the area of each of the vanes to help this thing lock, and the fluid can come through and redirect through the turbine back to the pump, from the turbine to the pump. It's just kind of this vortex, circular type of fluid flow. Now when we're cruising down the road, this will freewheel and kind of just flow with the rotary flow that's now occurring in a torque converter. But as soon as I accelerate, this will lock and help, again, redirect fluid, which multiplies torque. And the angularity of these fins is part of the design of how much torque can be multiplied. Okay, here's the turbine. Again, it splines to the input shaft. And this turbine is what gets influenced or has fluid thrown against its fins to make it start turning with the pump. Okay? And of course, as we're cruising, these 2 halves, their speeds become similar. And as they become similar enough, that is what enables the PCM to say, okay, it's time to engage the converter clutch, and it pushes it out. A little bit of extra fluid pressure built up inside to push this out and engage. And so these, when this engages, okay, when the converter clutch engages, these teeth here and these springs cushion, that one-to-one relationship, or cushions the engagement. But it becomes this half and the housing. Let me get the cover. Let me get the cover here once again. When the converter clutch is engaged, the pump and the turbine are actually locked together because the converter clutch has been engaged against this cover, locking the turbine to the pump essentially. And that's what we mean by torque converter clutch engagement. When we accelerate hard or tap the brake, then the converter clutch releases backwards and we're back into an acceleration type mode, or even a non-converter clutch engagement mode. So there you have it, the operation of a torque converter. Here's the clutch surface for the clutch lining of the torque converter clutch. Cushion springs to cushion engagement, one-to-one lockup. Here's the turbine. Here's the stator, the piece that redirects fluid flow and multiplies torque. And here's the pump. And fluid actually enters into the torque converter between this shaft, the input shaft, and the stator shaft. And also the small clearance that exists between the hub of this and the outer area of the stator shaft. So that's how fluid can actually come in and can come out, is through the hub section of the converter. Thank you.